in and out of the kidney. Okay, so here's our kidney here. We have our cortex, which is this area here, and then our medulla. Our medulla is made up of pyramids, and we have extensions of the cortex in between the pyramids known as renal columns. Looking at blood flow into the kidneys here, we have the renal artery, which splits into a segmental artery, then an interlobar artery, an arcuate artery. Zoom in for you guys. We have an arcuate artery, interlobular artery, and then you can see little branches off the interlobular artery that represent your afferent arteriole, moving towards the renal corpuscle. Right here is an actual nephron, so here's the glomerulus, the red, inside of the Bowman's capsule, and then there's your nephron loop. This guy right here is a cortical nephron, and this is a juxtamedullary, a corticomedullary, excuse me, not juxtamedullary, nephron. It goes a little bit further down into the medulla than the other. Moving out, we have our interlobular artery, interlobular vein, arcuate vein, interlobar artery, and then our renal vein. There is, I keep saying artery, interlobular vein, and then renal vein. There is no segmental vein. Okay? So again, just to review, renal artery, segmental artery, interlobar artery, arcuate artery, and then interlobular artery. And then interlobular vein, arcuate vein, interlobar vein, and then renal vein. No segmental vein. At the end of the pyramids, we have what are called the papillas. Okay, this is the apex right here of the pyramid. They empty into what's called a minor calyx. This is a good example down here. So we have a minor calyx and a minor calyx. These two come together to form a major calyx, and all your major calyces drain into what's called the renal pelvis. And then the renal pelvis will empty into the ureter. Now we're going to take this section right here, and we're going to blow it up. What we have, these are capillaries right here, here and here. And what this model does, really these capillaries should be on top of the nephron, but they're flipped off to the side so you can see them separate from the nephron, and the nephron clearly. So in the medulla, these capillaries are the vasorectal capillaries, and up here in the cortex, these are your peritubular capillaries. And again, you can see your interlobular artery. Give off an afferent branch, and here's your glomerulus. This is your Bowman's capsule. This is your proximal convoluted tubule, moving down to our descending limb of the nephron loop and the ascending limb going back up. This is your distal convoluted tubule, and then your collecting duct. And the collecting duct, again, will drain into the very tip, which I can't move it up any further, which is the papilla. Now we're actually going to take a renal corpuscle here and blow that up. And we get this little guy here. Here is your glomerulus. Okay. On it, you can see little itty-bitty podocytes. These are the visceral layer of your Bowman's capsule here. So here's your Bowman's capsule. Simple squamous epithelial tissue making that up. This is the parietal layer. Again, the visceral layer are those podocytes with the fenestrated capillaries of the glomerulus. This is the afferent arteriole. These are juxtamedullary cells. They are smooth muscle cells here, which means this is the efferent arteriole. What this is right here is the distal convoluted tubule folding back up and coming in contact with the vascular pole of the corpuscle. And we have a couple of cells right down here called the macula densa cells. These cells regulate, or they kind of keep track of what filtrate is looking like before it leaves the nephron. And they'll communicate with the juxtamedullary cells to affect the vasoconstriction or dilation of the afferent arteriole, which will overall affect filtration. So we call this the juxtamedullary apparatus, these juxtaglomerular cells and these macula densa cells right here. Lastly, we see the starts of the proximal convoluted tubule at the tubular pole, and these are cuboidal cells that have microvilli on them. And that's it for that. So save that.